Okay, let's get some drawing done, and here we'll now actually be drawing the playing field. Since we'll be drawing the playing field elements in white, let's add that color right after we define black up here. So that is white is 255, 255, 255. So since white is the presence of all colors, as opposed to black, the absence of all colors, and individual 8-bit values for red, green, and blue can range from 0 to 255, then white is 255, 255, 255. All other shades of gray down to black would have identical RGB values anywhere between 0 and 255. So in 8 bits, 2 to the power of 8 minus 1 is 255. That's where that number comes from. So the playing field will look like this. The colors here are inverted for better readability of the label. We will have 7 rectangles, which are very convenient in Pygame to create, manipulate, and draw. The first one is the net, the second one is the top boundary, the third one is the bottom boundary, fourth one is the left boundary, fifth one right boundary, and then the left paddle and the right paddle is numbers 6 and 7. So we have already named the rectangles which will not move using all caps letters, indicating that there are constant objects in Python. And likewise, since the paddles will move up and down and therefore change when the program runs, we have named them using lower caps letters, again in concordance with PEP8. So moving or not, all these rectangles, with the exception of the net, will interact with the ball, as the ball will bounce off the paddles and the top and the bottom boundaries. Also, when the ball hits either the left or right boundary, we know that the respective players has missed it with the paddle, and the opposing player will be awarded a point. So we can pick our values for net width, boundary thickness, paddle width, paddle height, and paddle offset any way that is aesthetically pleasing and, more importantly, to enhance gameplay. So for now, we will choose our boundary thickness to be 5 and our net width to be 10, with all measurements being in pixels. We'll choose the values for the paddles after we're done drawing the constant parts of the game. Those lines will be added right after the creation of the color constants. Pygame's coordinate system has its coordinate system origin in the top left corner of the window. Increasing the x coordinate will move to the right, increasing the y coordinate will move down. If you're familiar with the Cartesian coordinate system from mathematics, where the origin is bottom left and increasing y moves up, this may look unusual, but all the 2D game engines work that way. This comes from the original electron beam of a cathode ray tube, aka television, starting at the top left of the screen and moving right and down to draw the picture. Early video games could use the time it took for the electron beam to move across the screen to complete some computations before the beam arrived to draw an object. When Pygame draws a rectangle on the screen at position xy, it will treat those coordinates as the top left of the rectangle to be drawn. The top left corner is said to be the anchor point or hotspot of the rectangle. Thus, creating the top boundary is trivial, as its anchor point coincides with the origin and has a width equal to window width and a height equal to boundary thickness. So let's code that up. Top boundary is equal to, and we request from Python to give us, or Pygame, to give us a rectangle, or rect for short, with 0 as its x coordinate, 0 as its y coordinate, window width as its width, and boundary thickness as its height. The net is trickier. Its y coordinate is still at the top of the screen, so it's 0, but its y coordinate, its x coordinate is not in the center of the screen. We want the center of the rectangle to be in the center of the screen, which means we must move the anchor point's x-coordinate to the left. That means subtract it by half of the net width. So, therefore, the net looks like this. And that is Pygame rect. And now the x-coordinate, which is window net divided by 2 minus net width divided by 2. Y-coordinate still is 0. The net width is exactly that, so the net width, and the window height is the height of the net because it covers the whole window. Okay, so you've probably noticed that the layout for the top boundary and net code looks different. The simple reason for that is that PEBETA recommends do not exceed a line length of 80 characters or columns. The deeper reason for this is code readability, and connected to the reason why traditional newspapers, remember those, use a multi-column layout. About 80 characters, give or take, can be read by humans without the need to move their heads. Therefore, restricting the length of lines of code enables us to read and comprehend code more quickly, which is essential for efficient code review and improved code quality. So we can now add the 2 lines here, and we've done that at the just after we defined a rather constants. And then for the bottom boundary, the anchor point x-coordinate is 0, so we need to, and that is fine. But for the y-coordinate, we need to be lifted up again by boundary thickness. So let's do that. So our bottom boundary is then equal to Pygame of rect, so again 0, and this time around not 0, but it's y-coordinate is window height, and we got to lift it up by boundary thickness. Then the width is again the window width, and the height is our boundary thickness. So next to then our left and right boundary. So this just basically flips everything in x and y. So again, Pygame, oh, there's a typo right there. Pygame.rect, and then our left boundary starts at 0, 0. It has a thickness of index of boundary thickness, and then it's got a height of window height, and then the right boundary, and this rect, and this time around the x-coordinate is actually window width adjusted for the boundary thickness. Then a 0 for the y-coordinate. The width again is boundary thickness, and the height is our window height. Okay, so we've just added all this before our Pygame init, and now we can actually draw rectangles. So let's give that a shot. The drawing goes just in after where we filled the window. and with black, and now we can draw these. So let's actually go ahead and do this, and it's going to look like this. I'm going to explain this in a minute. So for the rectangle in a tuple of our net, top boundary, bottom boundary, and I'm grouping this here, and then the left boundary and right boundary, and that's all for now. And we just now tell Pygame to actually Pygame dot draw, and we want to draw rectangles, and then we want to draw it on the display surface, which is a window, in white, and then the current ray. So this collects all of our rectangles into a tuple, and we have a set of parentheses around the comma separated list, so it's a tuple. And then the for command actually iterates over each one, drawing it in white on the display surface. It's just the screen. So using iteration over a tuple saves us from typing the same draw command over and over, where nothing but the name of the rectangle to be drawn would actually be changed. So running that program at this stage, let's see, should actually give us our playing field. So we hit run and then say run module. Save the source, yes please. Python interpreter pops up, and we have our window with the playing field. So next up would be actually getting some motion in and drawing the pedals, which can move.